At a little after 7 in the morning on June 30, 1908, a farmer named Semyon Semyonov was sitting outside a trading post in central Siberia. The nearest city was hundreds of kilometers away. Around him was taiga, forest, marsh, reindeer country, and almost no roads. Then the northern sky split open. Semyonov described a sheet of fire spreading across the horizon. Heat struck his face so sharply that he thought his shirt had caught fire. Before he could pull it off, an invisible blow threw him from the steps. The sound arrived afterward, like artillery, one explosion following another. He was about 65 kilometers from the center. Closer to it, even key families were knocked from their feet. Tents were torn loose. Reindeer scattered or died. A recent review of the surviving accounts found evidence for at least 3 human deaths. For decades, the safe version of this story said nobody died because the forest was empty. The forest was not empty. Its people were simply far from the offices that kept records. The blast flattened roughly 2,000 square kilometers of trees, an area larger than London. The usual estimate is 80 million trunks. Windows broke hundreds of kilometers away. Seismic instruments registered the ground shaking, and pressure waves traveled around the planet. For nights afterward, people across Europe and Asia reported skies so bright that they could read newspapers outdoors after midnight. Something had exploded over Siberia with the energy of a nuclear weapon, decades before a nuclear weapon existed. And then, almost unbelievably, science left the scene alone for 19 years. The location was brutally remote. Russia moved through war, revolution and civil war. Reports survived in local newspapers, but no scientific team reached the devastated forest. Leonid Kulik finally arrived in 1927. He was a mineralogist, and he expected a gift from space, a crater filled with valuable meteoric iron. Instead, he walked into a forest arranged like evidence. Far from the center, trees lay flat with their tops pointing away from the blast. Seen from above, the fallen forest formed 2 broad wings, a butterfly pressed into the Siberian landscape. Near the center, something stranger happened. Trees were still standing, but their branches and bark had been stripped away. They looked like telegraph poles. And there was no crater. Kulik searched the bogs for holes. One looked promising enough that his team drained it. At the bottom they found an old tree stump. The supposed meteor crater had existed before the meteor. No crater. No large meteorite. No object to place in a museum. Only a pattern of trees and memories collected 2 decades after the morning itself. That absence created the mystery. A blast powerful enough to erase a city-sized patch of forest should leave something behind. If it did not strike the ground, where did all that energy come from? The serious argument divided between a rocky asteroid and an icy comet. A comet might explain why so little solid material remained and perhaps why distant night skies glowed. An asteroid fit the destructive shock and the kinds of objects that cross Earth's orbit. But empty spaces attract larger ideas. Tunguska was blamed on Antimatter, a miniature black hole passing through Earth, a natural hydrogen bomb, Nikola Tesla testing a wireless weapon, and an alien spacecraft that destroyed itself to save the planet. The black hole proposal even reached the journal Nature. It was answered there too. A black hole passing through Earth should have produced an exit event and a different trail of physical effects. They were not observed. Most of the exotic theories share one advantage. The missing object cannot contradict them. That is also their weakness. A theory that explains an absence by adding something even harder to detect has not filled the hole. It has made the hole larger. The ordinary explanation sounds less dramatic until you understand what air can do to a rock moving 15 kilometers every second. A space rock does not burn because the air politely rubs against it. At cosmic speed, the air in front of it cannot move away fast enough. It is crushed, heated and turned into plasma. Pressure builds against the front of the object while the back remains under far less stress. Stone is strong on a table. At that speed, it is fragile. Cracks open. Fragments spread. Each fragment exposes more surface to the atmosphere, which creates more pressure, more heat and more fragmentation. In seconds, one body becomes a widening cloud of material carrying almost the same momentum. Its motion turns into heat and a shock wave. The atmosphere becomes the surface it crashes into. That is an airburst. The object can release most of its energy kilometers above the ground. A large crater is not missing because the explosion was weak. The crater is missing because the main collision happened in the sky. The standing trees at Tunguska are part of that signature. Near the point directly below the burst, the shock traveled almost straight down. It stripped branches but did not push every trunk sideways. Farther out, the same pressure wave arrived at an angle and knocked the forest away from the center. A butterfly of fallen trees is not what a bomb buried in the soil produces. It is what a moving explosion in the atmosphere can produce. For most of the 20th century, that physics was reconstructed from old photographs and damaged trees. Then, in 2013, the sky performed a smaller version in front of thousands of cameras. On February 15, 2013, a roughly 20-meter asteroid entered the atmosphere over Chelyabinsk, Russia. It flashed brighter than the sun and exploded high above the city with more than 400 kilotons of energy. People rushed to windows to watch the light. The shock wave arrived later and drove the glass inward. Around 1,500 people were injured, many by broken windows. The asteroid never had to reach the street to hurt them. Dash cameras, security cameras, satellite measurements and recovered stones gave scientists something Tunguska never could. A modern airburst recorded from beginning to end. Models built to reproduce Chelyabinsk could then be tested against the older forest. 4 different modeling systems converged on a similar Tunguska culprit. The best fit was probably a stony asteroid about 50 to 80 meters wide, entering at roughly 15 kilometers per second. It released something like 10 to 30 megatons of energy, perhaps 6 to 14 kilometers above the ground. The ranges are wide because the evidence is old and different combinations can flatten similar forests. A faster, smaller body can resemble a slower, larger one. Burst height, entry angle, strength and composition trade places in the equations. But none of the successful models requires antimatter, Tesla or a spacecraft. Ordinary stone, moving at an extraordinary speed, is enough. One physical mystery briefly seemed to return in 2007. 8 kilometers from the calculated center lies Lake Chico, a deep, rounded lake with a funnel-shaped bottom. An Italian team proposed that a surviving fragment had struck there and formed the lake in 1908. It was a good scientific claim because it could be tested. Other researchers pointed out that the lake lacked several expected features of a fresh impact crater. Then sediment cores told the more damaging story. Layers at the bottom appeared to be older than 1908, probably much older. Lake Chico may be unusual, but the current evidence does not make it Tunguska's missing crater. Researchers have also reported microscopic grains near the blast center that may be meteoritic. None has become the unquestioned fingerprint of the original body. We still do not possess a labeled piece of the Tunguska object. So the event is solved at one level and open at another. We know the class of event, a cosmic airburst. We probably know the broad kind of object, a medium-sized stony asteroid. We do not know its exact size, structure, angle, burst height or identity. The atmosphere destroyed the evidence while creating the disaster. Here is where I stand. Tunguska is not a mystery because science has no explanation. The airburst explanation accounts for the missing crater, the standing central trees, the outward forest pattern, the global pressure waves, and the enormous energy. Modern simulations and Chelyabinsk make that explanation stronger than it was when Kulik first entered the forest. The honest uncertainty is narrower. Asteroid or comet? Exactly how large? Exactly how high did it break apart? Which reports belong to the event, and which were reshaped by 20 years of memory? Those are real questions. They do not require us to pretend that every explanation is equally likely. NASA newer estimates suggest Tunguska-sized events happen on the scale of thousands of years, not every few centuries. Rare does not mean imaginary. Chelyabinsk arrived without warning, and it was less than half Tunguska's estimated width. That is the part of this story that matters now. The dangerous object is not always the dinosaur killer large enough for us to notice years ahead. It can be a smaller, darker rock approaching from the direction of the sun, difficult to see until the atmosphere announces it. In 1908, that announcement landed over forest, moved the same butterfly of fallen trees onto a modern city, and the missing crater would be the least important mystery. What unsettles you more? That we never recovered the object, or that an ordinary rock can produce a city-sized explosion without touching the ground? Tell me in the comments. And if you want more mysteries where the evidence is stranger than the legend, subscribe. That's what we do here.